Now, how to write this particular set into the roster form? So here we have to find out the set of all even positive integers. Okay, so here we have to find out here we are required to find out set of all. Suppose that particular set is a capital A and it is equal to, and within a curly bracket we have to write down the elements of this particular set in a roster form. Okay, so set of all even positive integers. So basically the positive integers starts from 1, 2, 3, 4, 5, 6, 7, 8 and so on. But we require the less than 7, means from 1 to 6. This is what we required. But we require here even integers only. So the even integers are the 2, 4 and the 6. So the elements of this set A will be the 2, 4 and the 6. Okay. So the set is given. Okay. So the set is like this. If the set is like this, then we can represent this particular set into the roster form in this particular way. Now here again we have one set of all natural numbers. So the natural numbers are starting from 1, 2, 3, 4, 5, 6 and like that. But we require only that natural numbers which are dividing this particular number 42. Okay, so let's that particular set is capital A and here we have to write down the elements of this particular set. But the elements of the set A is nothing but which divides the number 42. So let us consider the 1. So 1 is perfectly dividing the 42. So 1 will be the element here. Okay. So 1 will be the element of our set. 2 is dividing the 42. 3 is dividing the 42. 4 is not dividing the 42. So 4 is not the member of this particular set. 5 is not dividing. 6 is dividing. 7 is dividing. 8 is not dividing. 9 is not dividing. 10 is not dividing. 11 not. 12 is not. 13 no. Yes, 14 is there. 14 is the number which divides this 42. Then 24 is, I think 21 is a number which is dividing this 42 and 42 itself. Okay, so a set of all the natural numbers which divide the 42. So these are the natural numbers which are dividing the number 42. Okay, so like this. Okay, so the final output will be this. So this particular set when represented in a roster form will looks like this. Now consider these particular 4 sets. So the first set is the set of the natural numbers which is represented by the capital N. The second one is a set of the integer numbers which is represented by the W. And the set of the negative integer numbers represented by the capital A. Set of the first 500 integer numbers represented by the capital A. So in this particular 4 sets, one thing is common which is called as the ellipsis. So ellipsis is nothing but these particular 3 dots. So it is in this particular case the ellipses are present at the end of that particular set. Here the ellipsis is present before the start of the set and after the end of the set. Here ellipsis is present before the start of the set, and here ellipsis is present in between the set elements. So if the elements are infinite, such as in case of the natural numbers, then that particular nature is represented by using the ellipsis. So some few elements are listed, and after that the three dots are written. If there are infinite elements in a right hand direction as well as in a left hand direction, so this fact is represented by using the ellipsis at the start and end of that particular roster form representation. If it is it has infinite elements to at this before the start, and after that it is the last element in this particular roster form, then this particular fact is represented by using the again ellipsis. So we cannot here write down the 500 elements in a same set. So that particular fact is represented by using few of the elements and then the three dots and then the last element. So this series will go on increasing up to the 500 number. Okay. So if it is a roster form, then ellipsis is too much important to represent that the series is infinite series. Okay. So like this we have this particular ellipsis concept.